Hello, my name is Jeffrey Wan, and I'll be explaining three methods of enumerating 5 Boolean variables. In this project, we're given 5 variables, or judges in this case, and we have to count the number of votes within the variables. So, counting number of ones in variable x1, x2, x3, x4, x5. So, the first method we'll be looking at is the two-level methods, where all 5 variables get enumerated through one module. The configuration of the input and output variables are shown on the paper. As you can see, 5 variables x1, x2, x3, x4, x5 go into a module and turned into variable f2, f1, f0, which represent the number of ones in the output. The possible output is listed on the side, showing 3-digit binary code from 0 to 5. First was making kernel map for each f2, f1, f0 variable. f2 is 1 when number of vote is 4 or 5. And I actually made a simple table over here to list all the number of votes in each slot of the kernel map, so I can translate into this map easier. So f2 is 1 when number of votes is 4 or 5. The number of vote is 4 right here, and number of vote is 4, 4, 4, 4, 5. So the kernel map looks like this. SLP form using the kernel map above. As for f1, I did the same, and then I was able to obtain the simplest SLP form below. For f0, I did the same, 1, 3, 5, and created a kernel map and got the simplest SLP form. And I calculated the cost of each step. So f2 has 5 AND and 4 input, 1 OR, 5 input, 6 gates, 25 inputs, which means it has 31 cost. So I did the same for f1, for f0, which cost a lot because SLP form was very long. So the total cost by adding all the terms was 231 cost. Now, let's implement the two-level method program into the D0 board to see if it actually works. So first step you need to take is go to Tools, and there's Programmer section. And you need to click that. And I actually set up everything before the video, so all I need to do is just press Start, and it'll say the progress was successful. So I set starting five pins right here to 5 inputs of the program, x1, x2, x3, x4, x5. Let's see if it actually works. x1 is 1. There's 1 person voting, and also this output indicates that f0 is 1, which means it's 0, 0, 1, meaning it's 1. Let's say x5 votes. Oh, no, it's 2. And f1 is 1. So it's 0, 1, 0, meaning there are 2 votes in the system. And if we turn on, let's say, x2, now it becomes 3 votes. And this becomes 0, 1, 1, meaning 3 votes are in the system. Let's just turn on rest of the buttons, 3 and 5. Now it means f2 is 1 and f0 is 1. So 1, 0, 1 is 5. The second method is hierarchical multi-level method, and in this case I grouped x1, x2, x3, x4, x5 into group of 2 and 3. Now, the module A combines the input of x1 and x2 in order to create A1 and A0, which represent the number of votes from those two values, which goes same for B1 and B0. This represent the number of vote in variable x3, x4, and x5. And I listed all the possible values that A and B and F can take. But look at A. A only has two possible votes. 0, 0 represent 0 votes. 0, 1 represent 1 vote. 1, 0 represent 2 votes. 0 to 2 is all you need to count x1 and x2. So 1, 1 variable of A1 and A0 is don't care variable. For hierarchical multi-level method, I created kernel map for each output variable. Here are the kernel maps: A0, A1, A0, B1, B0, F2, F1, F0. Mentioned before, A1 and A0, when both of them are true, which is when A1 and A0 is 1, 1, we put don't care value. I calculated the cost of each step starting A1. So A1 costs 3. A1 has cost of 3, and A0 has cost of 13, so on and so forth. B1 13, B0 27, F2 10, F1 28, F0 13. The total cost ends up being 107 when I added all the costs from each step, which is significantly lower compared to two-level method. Now, let's implement the hierarchical multi-level program into the E0 board to see if it actually works. Let's say x5 votes first, and it becomes 1, and this is 0, 0, 1. So let's try the other. Let's say x3 votes. Now it's 2, and 0, 1, 0, meaning 2. So this works. And x1 votes. Now it's 0, 1, 1, and 3. So 3 people vote. And let's just turn on the rest of the buttons as before. This 3 LED represent 1, 0, 1, and this is 5. Let's test high-level behavioral. So when x5 votes, 1 vote registers, or 1 registers, 2 votes, 3 votes, 4 votes, 5 votes. This is the method of calculating the 7-segment display. So 7-segment display means there are 7 segments in the display: A, B, C, D, E, F, G, and it is used to display the number on the E0 board right here. Let me explain how the kernel map of A works. So when the value is 0, 0, 0, the value is 0. So 0, when you draw 0 in there, A is turned on. So this value is 1. However, when you look at 1, 0, 0, when it is 4, when you draw 4, A is turned off. So this value is 0. Final question is which one of these method is the most efficient? Well, let's compare. So here are 3 flow summaries. The flow summaries after the compiling of 3 methods, and you can see that two-level method uses the most amount of logic element out of 3. Let's compare. So two-level uses 14 combinational functions. hierarchical multi-level uses 13 logic elements, while high-level behavioral only uses 8 logic elements. So, just looking at total logic elements, we can say that high-level behavioral is the most efficient and effective method of counting the votes of 5 variables.